Welcome everyone to the lecture series of the course Marketing Research and Analysis. We have been dealing with the non-parametric tests since the last 2 lectures, 2 to 3 lectures. We have tried to understand what non-parametric test means all about and why they are used and where they are used. What are the conditions in which parametric test does not work, and in place of that we tend to use the non-parametric tests. We have conducted several non-parametric tests, including for example the Mann-Whitney U test, the Kruskal-Wallis test, then we did with the Sines test, then the Wilcoxon sign rank test, then we did it with the Spearman's correlation test, which is a similar test with the Pearson's correlation. So, it is a test of association like the correlation test you have for the Pearson's correlation, but this is for the non-parametric. So, continuing the same, we had talked about the chi-square test and the McNamara test. So, these 5-6 tests we have already discussed, and maybe today we will wind up with this lecture on non-parametric, maybe 1 or 2 more techniques we will cover up, and I will show you how to conduct those tests on even the SPSS, and then we will wind up this lecture on non-parametric. So, we were talking about McNamara. So, what is this McNamara test? Let us go back and think about what we had discussed in the last class. In the last lecture we discussed that McNamara is a similar test to the chi-square test, which follows a chi-square distribution. You remember a chi-square distribution? So, a chi-square distribution is more of a right skewed distribution, right, which and the McNamara follows follows the chi-square distribution. But the problem is, then what is the difference between the chi-square and the McNamara test? The difference is that a chi-square test can be done between several more than 2 variables, let us say, and the variables will be nominal obviously. So, let us say we can conduct a 2 cross 4, a 3 cross 4. So, this kind of studies can be done in a chi-square test, but when you do a McNamara test, it is restricted to only a 2 cross 2 contingency table, right. So, this is the limitation of a McNamara test, otherwise the distribution that it follows is similar to the chi-square distribution, right. So, how do you do this McNamara test using SPSS? So, let me explain that. So, what I will do is I will show you one of the slides which I have prepared. So, McNamara test, so this is the data. So, the data is between 2 things. So, what is saying, let us see. So, pre-situation and post-situation, as you can understand. So, what is this pre-situation and post-situation? It is a test where people who are smokers and who are non-smokers, they were taken, and these people were shown an treatment like an advertisement which talks about the ill effects of smoking, and then they were checked what is the impact of this advertisement on the people's mind. So, did their smoking habits change or did it remain the same, okay. So, in this case we have taken 0 as non-smokers. So, people who do not smoke are taken as 0, right, and the people who smoke are taken as 1, right. So, okay. So, this taking this, so we have created the data. What is the how does it look like pre, that means before the advertisement, what was the condition. So, let us see the data. So, in the pre situation you can see, so 1 were smokers. So, these were all smokers, and these are non-smokers, right. So, as you go down, so these are non-smokers 0 0 0 0 all are non-smokers. So, and after the advertisement was shown to them or the treatment was given to them, so he is a smoker, continues to be a smoker, again smoker, but this is somewhere here you see it is a smoker. After the advertisement it has or after the treatment he has converted into a non-smoker, he or she has been converted non-smoker. So, similarly you can see, so 1 0, so again conversion is there, here there is a conversion, here there is a change in mind, here again. So, here they were already non-smokers. So, let us see, has there been any change with the non-smokers? So, that non-smokers became smokers, something like that? No, I do not think anything has been there. So, there has been no absolutely change with the non-smokers, they have been non-smokers have stayed as non-smokers as before, right. So, now to conduct a McNamara test, what we will do is, how do we test this? So, let us go to analyze. Here there are two ways of doing it. You could have done, you can do with a non-parametric test, going into the non-parametric test, but then I will show you another way which is more simpler. Now go to the cross tabs, right. So take any one of them as the pre-situation, as the maybe then the row, and post situation in the column. Now what do we want? We want the McNamara test. Now if you can see here, the McNamara test is there, right. So we take this, go with this continue, and we know that in a chi-square test the minimum cell size has to be 5, right, less than 5 it does not work. So now let us see what is the output. So if you go to the output, we will see the pre-situation versus post situation, there are 40 sample respondents and there is no missing value. Pre-situation was that non-smokers were non-smokers who remained non-smokers were 20, non-smokers who became smokers 0. So, there no non-smoker has become a smoker, smokers who became non-smokers are 5 and smokers who remained smokers is 15. So, is this data telling us some significant change? Now, at the moment if you see from the McNamara test here the value, now we can see that it is coming 0.063. Let us assume our significance level that we have taken is, usually we take it at a 5% significance level. So, if you take a 5% significance level, what do you infer from here? You infer from here that the null hypothesis is not to be rejected, because it is this p value is more than 0.05. Now, let us make small changes in the data set. Let us go back to the data set and make small changes. So, let us make some changes and see in the data set if our results are varying now. So, let us go back to the data set again. So, what I will do is I will change some of the data. For example, let me change this as 1, right. Let us assume he was also a smoker earlier, right, and you can also convert some of these as as smokers, let us say, right. This is but then we do not want to have the adverse effect, we do not want to see that. Let us assume still, if you want we can. So, some non-smokers have become smokers, I mean to say that, right. So, this is another, let us say, smoker. So, let us take this much and check has there been any change in our result. Now, if you go by again this, right, and you run the test keeping everything is same. Now, you see because you converted 2, right, 2 smokers. So, non-smokers who became smokers is 2 now. So, it is a very dangerous effect which has shown, and smokers who were earlier smokers and now they are non-smokers is 8, and smokers who remained smokers are 15. So, it has become more poor, more the significance value has become more poor. So, instead of this, if we do one more thing, we will, instead of this we will not make it, let us say we will not make it, we will keep it 0 as it is, right. So, let us make it 0 0 and this is also 0, we do not want, right. So, this is 1, this is 1 0. So, this is become a sum of them more, let us say take one more, let us say, and we make this also 0. So, I think okay, it is done. So, now let us run it, let us see is there any change. So, if you go by this and you check. So, now if you see what I have done by only changing 2 things, I have, this is just an experimentation, you can try several things while you do. So, now just what I have done, you see the non-smokers 0 are non-smokers, 1 is a smoker. So, non-smokers who remained non-smokers after the advertisement is 17, non-smokers who became smokers 0, smokers who became non-smokers, now we increased from earlier I think it was 8 or something, we made it 10, right, and this has resulted in smokers remaining smokers also has gone down. As a result, you see the McNamara test says that there is a significant change in the in the people's smoking habits after they watched the advertisement or they went through the treatment, right. So, this is what you have to write down when you write a result of the test, right. This is a significant test and the null hypothesis is rejected, that the advertisement has got no effect on the smoking habits, rather it has got a smoking impact on the smoking habit of people, right, a positive impact. So, this is one of the things that we were doing. Now, let us go back to the our PPT. So, we have covered this. So, let us okay. In our example, P is equal to the significance level is equal to 0.27, which means that the proportion of non-smokers is statistically significantly different after the intervention, which I am saying as the advertisement, as compared to before. Or put in another way, the change in the proportion of non-smokers following the intervention was statistically significant. So, this is how you write. So, that means what? That at 0.05 level, right, it was significant, and you got, let us say it was significant at 0.027, right. So, this is how you write it in the research reports and all. Okay, today we will do one more test, but before I do one more test, if you remember, we had done one test which I said I would do it later on, the analysis for it. So, that was a Wilcoxon test. You remember that Wilcoxon test? Okay. So, Wilcoxon signed rank test, this was a test which is basically like a paired sample t test. If you remember by any chance, if you will okay, a paired sample t test is a test where a before and after situation happens, right. So, what happens is whether how does the person react before and after, let us say after some treatment. Let us say you have been given some medicine or some kind of a method of teaching, some kind of a method of, let us say, some experimentation has been done, and what is the effect of that medicine, right, as we did earlier also. So, we will see what is the change in this case. So, Wilcoxon signed rank test, this is a test in which the pain of people was measured at two same people. Now, what does it, why I am saying it is like a paired sample t test, because the sample remains the same. So, the sample, there is a group of sample of, let us say 25 people, and their pain score was recorded before some medicine was given, the pain score was recorded. So, after recording, can we say that because of this medicine there has been a change in the pain among the patients? So, this is the test. So, Wilcoxon signed rank test is nothing but a non-parametric test for the paired sample t test, right, that you were doing earlier in the t test, right. So, how do you do this? So, you can see Wilcoxon signed rank test. So, you go to so there are two related samples, right. So, so let us go to the two, so week 1, so this is 1, week 4, so this is the one. So, we take we want the descriptives, we continue and okay. So, let us go to the result and check the result. So, what is the result saying? Now, as per the result, if you see, if you look at the test statistics, right. So, the z value is minus 3.706 something, and if you look at the significance value, sorry, the significance, thus it says there is a significant change in the pain of people from in comparison to the week 4 and the week 1. So, that means the medicine has worked wonders, right. So, week 1 pain score mean was 6.8, week 4 pain score was 4.8. So, that means the pain has significantly reduced, and this is proven from here. So, this is another test which is very important, and I have said the Wilcoxon signed rank test is a more powerful test in comparison to the sign test, right, which we have already seen earlier. So, these are the two tests which I was talking about, and today we will move into one more test, the Friedman's test, right. So, what is this Friedman's test? This Friedman's test is nothing but another test which is similar to the analysis of variance test. Whenever you have two groups, so you use a independent sample t test, right, or a paired sample t test. So, independent or in non-parametric you have for that the Mann-Whitney, or you have the Wilcoxon, for example, right, say. But if you have more than let us say two groups, let us say you have 3 groups, group 1, group 2, group 3. Now, there if you do a independent sample t test, that means between group 1 and group 3, group 1 and group 1 and group 2, group 1 and group 3, and group 2 and group 3. So, there will be 3 tests, and if you do 3 tests, we have learnt earlier also that the type 1 error increases and the inflation, the alpha gets inflated, right. So, to avoid that you do a one way ANOVA, correct. So, to have a one way ANOVA in the non-parametric you have a similar test called the Kruskal Wallis. So, which already we have discussed, but what if the in the one way ANOVA the sample is repeated again and again. That means, in a test in the one way ANOVA you have the dependent variable as some kind of a continuous variable, let us say, and the independent variable as a categorical variable. But suppose we have a repeated measure, that means the same sample is getting repeated more than 2 times, right. You are checking for the same sample, the change in the value of the sample for of 3 times, 4 times, 5 times. So, then each these groups are having the same people, but only the experimental values are being recorded maybe 3 times or 4 times, if it is, let us say, something like this. So, in such a condition, you use a technique called the in a parametric case, you use the one way repeated measure test, which is the right. So, but here similarly in the non-parametric case, you have a test called the Friedman's test, or this test, which is similar to this one way repeated measures test, right, ANOVA, this is right. So, let us see what is saying. It is a non-parametric test alternative to the one way ANOVA with repeated measures, that is what I said just now, right. So, it is being repeated, the same sample is getting repeated. It can be considered as an extension, yeah, that is true. If you have a you had a paired sample t test, what was happening in the paired sample t test? In the paired sample t test, the same sample respondents were being checked 2 times, maybe once before and once after, but here it is an extension of that, that means it is maybe not 2 times, but 3 times, 4 times or more than that, right. It is used to test for differences between groups when the dependent variable being measured is ordinal. It can also be used for continuous data that has violated the assumptions. So, it is a very powerful test. So, it can also work for continuous data that has violated the assumptions, but the question is if if it is a continuous data, generally one will go for a one way repeated measure ANOVA, but then the condition here it is saying it has violated the assumption of the normality. So, that is why one way ANOVA will not work, repeated measure ANOVA will not work. So, in that case we use this Friedman's test. Okay. It is particularly useful when the sample size is very small. Now, that is very interesting. So, if you have a one way ANOVA, you do some kind of a parametric test, if the sample size is too small, then it does not work well, but this test has the capacity to run smoothly, to run function well even when the sample size is small. So, let us see a test, I will show you. There are some assumptions first, let us discuss. One group that is measured on 3 or more different occasions. I said one group, that is the sample respondents are the same, are measured once, twice, thrice, maybe 4 times. Okay. The group is a random sample, it is a random sample. So, there is no bias, okay, of selection. Your dependent variable should be measured at ordinal or continuous level. So, in ANOVA, if you remember, I had said just now also I said in the ANOVA what was happening, the dependent variable was continuous, right. So, it was continuous and independent variable was categorical. Okay. So, examples of ordinal variables include Likert scales, right. Amongst other ways of ranking category, 5-point scale explaining how much a customer liked a product. So, these are some of the examples, and continuous variables include revision time, how much time measured in hours, intelligence maybe in IQ, right, exam performance measured from in a scale of 0 to 100, what is your percentage in the exam, right, weight measured in kg, etc. So, if the dependent variable is in this kind of a data, no issues, it is okay. Samples do not need to be normally distributed, fantastic, obviously otherwise what is the use of a non-parametric test. Okay. Now, let us take this example. 6 raters means there are 6 people who are experts, they are evaluating 4 restaurants. Okay. The results of the experiment are displayed in table, next table I will show you. So, what are these people doing? They are rating the restaurants and trying to say which restaurant is better than the other. Okay. If you cannot make the assumption that the service ratings are normally distributed, right, for each restaurant, then the Friedman test is appropriate, right. However, if it would have been normally distributed and the sample size would have been larger a bit, then we would have gone for the F test, right, but this is not the case. Our sample our ratings whatever they have given actually are non-normal. Okay. The null hypothesis in this case, you should actually kindly take a pause and start writing the null and the alternate here, right. Anyway, So, null hypothesis is that the median service ratings for the 4 restaurants are same or equal. So, that means median M1 is equal to M2 is equal to M3 is equal to M4. So, all the median values are same. So, M1, M2, M3, M4, right. What is my alternate? At least not all the medians are equal, at least one of them is unequal or not equal. So, maybe median 1 and median 2 are same, median 2 and median 3 are same, but median 3 and median 4 may not be same or any one of these, right. So, let us take this. So, there are 6 raters as I had said, 4 restaurants, restaurant 1 A, B, C, D. So, the first rater gave a rating of 70 to A, 61 to B, it is between 0 to 100, 82 to C and 74 to D. Second rater gave 77, 75, 88, 76, right. Third rater gave 76, higher the score better is the performance, 67, 90, 80. So, the third rater has given a higher score of 90, right, and 80 also. The fourth one gives A 80, C 96 and the others are 63 and 76. Similarly, these are the values. For fifth one 92 has been given for C, right, and sixth one 98 has been given for C and 86 for let us say D. So, now this is something, see this is a small table you can even see, but when you have to test it and say whether it is a significant difference or not, for that statistical test have to be conducted. Okay. Now, what we have done is we have tried to make a rank. Now, let us see what is the rank. Now, in this first row, just look at the first row, which is the lowest value? The lowest value is 61, right. Now, so 61 gets a 1, rank 1, rank 2 70, rank 3 74 and rank C. So, is it okay? So, 1, 2, 3, 4. So, now we will see here. So, which is the first rank in this among these 4? 75, first, then second, then 3, then 4. So, 3 1 4 2, is it there? 3 1 4 2, correct. Suppose sometimes just remember, even I have told you in some other test, if there is a suppose a same a tie is there in between 2, let us say this would also have been 75, let us say. So, in this case what would have happened? Now, 1 and let us say this is this would have been, let us say what is the rank, 75 is 1. So, this would have become 2, right. So, 1 and 2, that means this would have been the score would have been, now the rank would have been 1.5 and 1.5. Why? Now, 1 plus 2, because since this is 76 more than 75, this would have become 3 automatically. So, 1 plus 2 divided by 2, so that is equal to 1.5 each. If it is a tie, in that case you should have done that change. Okay. So, other things also you can do for similarly 1, 2, 3, 4, right. So, 1, 2, 3, 4 goes on, right. So, we have created, so in this table there is similarity, okay, for this value there is you see this is 1, this is 2, this is 3, right, and this is 4. So, now this value rank, when you come to the rank, what it should become? 2 plus 3, 5 divided by 2. So, each gets a 2.5, 2.5, let us see 2.5, 2.5, right. So, you have done it. So, total, now this is the total of the ranks, 14.5 for A, 6 for B, 24 for C, 15.5 for D. Now, this is the formula. I have got this formula because it is very tough to write these things. So, I have copied this formula from a I have downloaded it. So, Friedman's the formula is 12 divided by R into C. What is R? Number of rows, number of columns C into C plus 1 into summation of R square, each for each block, right, each group square minus 3 into the row, the blocks into C plus 1. Now, let us use R is equal to 6 in our case, 6 raters are there, 4 restaurants are there, R1 was 4.5, 14.5, 6, 24, 15.5. Now, putting into the formula, you will see if you do this, then the score that comes is 16.25. Now, 16.25 is the Friedman's test value, right. Now, since you got a 16.25, but what is the table value you have to compare? The table value is you have to look at from the chi-square table, right. From the chi-square table you have to compare it with the chi-square table. So, chi-square table for 3 degree of freedom, why 3? Because the degree of freedom in the Friedman's test is measured as C minus 1. So, C was, what is the C? You see the C is the number of groups you have. So, where 4 groups, so it is like a within, right. So, so C minus 1, right. So, you have 3. Now, for 3 degree of freedom the chi-square table. So, if you look at the chi-square table for 3 degree of freedom at 0.05 significance level, the value is 7.82. Now, since 16.25 is greater than 7.82, what is your assumption? What is your what inference will you draw? The null hypothesis is rejected. Why? Because if you look at the table value is 7.82 and the calculator value is somewhere 16, right. So, if this is the null hypothesis rejected. So, what is the null hypothesis? The null hypothesis said that the median scores of all the restaurants are same, right. So, that is rejected. So, that means there is a difference between the median score of the restaurants. Now, how do you write this? You see, there was a statistically significant difference among the restaurants. So, chi-square at 3 degree of freedom is equal to 16.25 and p is equal to 0.001, right. So, I will show you the same test, I will show you on the SPSS also and we will compare. So, that is how we got this 0.001. Now, what you can do is, suppose you want to see whether the relationship is significant differences between the each restaurant is there or not. For example, so A, B, C, D were there. Now, okay, there is a difference, null hypothesis rejected, but what is the relationship between A and B, A and C, A and D, B and C, B and D and C and D. So, you want to check it, for example, you can do it. So, to do that what you have to do is you have to just I think I have written, yes, you have to do a post hoc analysis with Wilcoxon signed rank test, because I said Wilcoxon signed rank is a paired test. So, paired t like a paired t test t test. So, you can do, because the sample is same here, right. So, 6 raters, the raters are same. So, you can do a study between A and B, A and C, A and D, goes on 6 studies, but remember this is important, but with a Bonferni correction applied. Now, what is a Bonferni correction? It says, now suppose you are taking a significance level of 5%, right. Now, you are conducting 6 tests. So, you have to divide it by another number of tests. So, how much is remaining? Now, for example, I have done it 0.065 divided by 6 is equal to, so the new significance level is not 5%, but is 0.0083, that means it is you can say it is 0.8, right, 0.8, right. So, this is the new significance, it is less than 1% and you have to check it at this less than 1% significance level. If your table value comes if your study gets significant by comparing with this, then you can say what is the relationship between maybe A and B, A and C, A and D, individually you can check and say, right. So, this is I will show you how to do this. So, this is the same case 1, 2, 3, 4, 5, 6. So, the 4 restaurants are there, the scores have been given and let us now do it. So, go to analyze, go to non-parametric tests. Now, what will you do? This is a multiple groups, same sample, but multiple times it has been taken, 4 restaurants, for 4 restaurants same people. So, which is the one I should be using? If you use your logic here. So, I am using k related samples, they are not independent, they are related, same people, right. So, I am taking all the 4, correct. So, I have taken. Now, the Friedman's test is the normal choice, when you take several related samples, the normal choice is Friedman, right. So, let me take the descriptives and check. So, what is my assumption coming, my study saying? The mean rank of first one is 2.42, second one is 2, third restaurant gets a 4, the mean rank is 4. So, it is quite high, restaurant 4 is 2.58 and looking at the test statistics, it is significant at what level? 0.001, it is significant at 0.001. So, that means what? We can easily say from here that there is a significant difference between the service offered by the restaurants as per the 6 raters. Okay. If you want to compare it individually, you can make a comparative study between restaurant 1 and 2, restaurant 1 and 3, restaurant 1 and 4, similarly 2 and 3, 2 and 4 and 3 and 4 by making individually a Wilcoxon signed rank test, but only thing is, remember, you have to take your significance level, not 5% or 10%, whatever you take, it has to be divided by the number of tests, that is in this case 6, right. So, if there are 3 groups, how many tests? If there are 3 groups, there will be only 3 tests. Suppose A, B, C, A and B, A and C, B and C, 3 tests. So, if it is 5%, for 3 tests it will be 5 by 3. In this case you have 4 groups, so there are 6 tests. So, 5 by 6 and whatever you have to compare accordingly, right. So, this is what is the Friedman's test, and there is one more test which I will talk about. The last test is KS test. This is the last test which we are discussing today. So, this test is a simple non-parametric method for testing whether there is significant difference between an observed frequency distribution and a theoretical. You see, in many times when you talk about models, so there you need to understand whether there is a difference between the observed frequency and the expected frequency or not, right. And if there is no difference, then that means the model is fit or strong, even that we saw in the chi-square test, right. So, the KS one sample test is more powerful than a chi-square test, since it can be used for small samples unlike the chi-square. This is a very important thing you need to remember. Okay. Now, how do you do this? The null hypothesis assumes no difference between the observed and the theoretical distribution. So, what the null hypothesis saying? There is no difference, but as a researcher, what do you want? There needs to be difference, because that is what the alternate hypothesis talks about. So, the difference that D is calculated as maximum of the absolute difference between FOX and FRX. Now, what are these two? FOX is equal to observed cumulative frequency distribution of a random sample of n observations. Now, FOX is equal to k by n, where k is equal to the number of observations equal to or less than x and divided by the n total number of observations. FRX is the theoretical frequency distribution. So, let us see this one of the problem. So, this is the more or less the same thing. The acceptance criteria is if calculated value is less than the critical value. If calculated value is greater than the table value, you will reject, the same thing rise. So, this is a study of 60 students, right. Each students were interviewed to join the drama club. So, BSc 5 people, BA 9 people, BCom 11 people, MA 16 people, MCom 19 people. It was expected that 12 students from each class would join the drama club. So, using the KS test to find if there is any difference among student classes with regard to the intention of joining the drama club, let us check that. What is the null hypothesis? There is no difference among students of different streams with respect to their intention of joining. So, we want to say is there a difference in the thought process of people with a BCom graduate degree and a MCom degree, or a BA and a BCom? We want to compare. We develop the frequencies for the observed and the theoretical distributions. So, what it says is the number of students interested in joining observed is 5, 9, 11, 16, 19. Go back. So, 5, 9, 11, same thing, right. What is the theoretical? Since there are 60 people and there are 1, 2, 3, 4, 5. So, 5 groups. So, we will divide it by 60, 60 by 5 is equal to 12 for each. So, what is my observed frequency? 5 by 60, 14 by 60, how? Now, 5 plus 9, right, 14 by 60, then 14 plus 11, 25 by 60, then 41 by 60, 60 by 60. Okay. What is my theoretical distribution? Now, 12 by 60, 24, 36, 48, 60. Now, we will take the difference between these two, this and this, right. So, what it gets? 12 minus 5, 7 by 60, 24 minus 14, 10 by 60, 36 minus 25, 11 by 60, 48 minus 41, 7 by 60, and this is 0, right. So, if you calculate the maximum now difference, it is where is the maximum difference? This one 11 by 60. So, this is the maximum difference 11 by 60, which is equal to 0.183. Now, table value of D at 5% significance level is given by, this is the formula. So, 1.36 into root over of n, which is coming at 0.175. Now, you see your calculated value was 0.183, your table value is 0.175. So, what will you do? Since table value is less than the calculated value, the null hypothesis is rejected. So, since the calculated value is greater than the critical value, we reject the null hypothesis and conclude that there is a difference among students or different streams in the intention of joining the club. Well, I hope this is a very simple test, but very powerful test. It can be utilized. All these tests of non-parametric tests that I have tried to explain you and make it as clear as possible to my extent of knowledge, right, my level what I can think of. But non-parametric tests are not to be taken lightly. They have a very important role, because many a times in life the data does not behave normally. So, in such a condition, the best thing is to go for a non-parametric test and make your research inferences, draw your research inferences. Okay. Thank you so much.